Okay, so we're going to talk about normal distribution. If they've given you normal distribution or you've seen anything like it before, they give you some hill like this. It looks like that. And when we're talking about that, we're usually talking about collecting data that's normally distributed around a specific amount. That amount is usually known as the mean, and they sometimes represent it with the variable x bar. They put a little line on top of it. Okay, and what this really is the mean or the average of something. Okay, so let's say we're talking about grade 12 data management grades. Okay, so grade 12 data grades, and we're going to say the average grade is 65%. Okay, so we've tallied up all the grades for every class throughout the year. Maybe there's like 5-10 classes. Who knows how big the school is? And we'll say the mean is at 65%. So actually, it's not a great number to use because we're going to start talking about percentages, but that's the grade we're talking about. Okay, so that's where the mean is. The mean is a 65%. So how they've built this normal distribution is they've probably taken, do you remember histograms? Mm-hmm. They've built a histogram that essentially has a look like this. Okay, so it starts to build up like this. And if you notice, the histogram will follow a pattern that kind of looks like it's following this wave. Okay, so that's essentially some type of histogram. So they've discovered that it essentially makes this type of curve to it. Okay, so they've built this off of a large histogram. Now, what you're going to find with normal distribution is we're going to talk about what percentage of a class is in what's called a deviation. A deviation is how far from the mean we are. Okay? And there's a big process to find standard deviations. And you probably haven't talked much about it yet. We're not going to go into too much detail because it is a long process. We need data to do it. Yeah. You guys have talked about it? Yeah? Okay, so a standard...
That's with the circle looking.
This guy here, right? Yeah. So this is a deviation, okay? And in our example, we're going to say a deviation or a standard deviation is equal to 10 marks. Instead of percentages, actually, let's use marks. So 65 marks. We'll do that instead, okay? So this is considered one positive deviation from the mean. It's to the right. This would be considered one negative deviation to the mean.
Is that like integers?
Yeah, like integer stuff, right? To the left. A deviation is 10 marks. So what that means is to go one deviation up would be 10 plus 65 would be 75. And then one deviation down would be 10 minus 65, which would be 55. Great. When we talk about deviations from the mean, we really only focus on going up 3 or down 3. So this would be considered 2 deviations from the mean, or positive 2 deviations from the mean. And then finally, 3 deviations from the mean. And we'll talk about why we only go up to 3. Okay, so negative 2 deviations from the mean and negative 3 deviations from the mean. If we follow that, what that means is the next number is 85, and the next number is essentially 95. Well, here we go down to 45 and 35. Okay, so the deviation, we used a process to find a standard deviation. We discovered the deviation was 10 in our question. It was 10 marks, okay? What's important about this is all this information is telling us about the general population of the class. What it's telling us, and what we're going to find out, is when information is normally distributed, 68%, okay? 68% of a population is within one deviation of the mean. So, and you can see that by the size of this hump here. Okay, so this deals with 68% of all the population is within here. Okay, so I'm going to kind of just highlight it.
So what if the middle number was 95?
Well, then it would have to go up to 105 and down to 85.
So the middle would have been 95%, right?
Yeah, now that'd be pretty unrealistic for a class, for the mean to be 95, right? So we chose this number here. We've just made these numbers up. So what this means is 68% of the people who took this course have a mark between 55 and 75, okay? From there, we'll do the next part in blue. Within 2 deviations, okay, that's actually considered 95% of the population. Okay, we'll just kind of highlight above it. 95% of a population falls within there. Okay, so I'm just going to write it on the side here. 95% falls within all of 2 deviations here. Okay, and maybe we'll use some highlighting to help us out with that. And the reason we go up to 3 deviations is because technically 99.7% of a population will fall within 3 deviations of any mean as long as it's normally distributed. Okay? So this is all of this area in here. 97% falls in here. 68% falls in here. And 95 falls within this area. And we'll write the 95 here. Okay, so that we can kind of see. Okay, so what does that mean to us? Okay, if we're looking at the Pope John Paul class, and this is their statistics, we discovered that 68% of the students got a mark between 55 and 75. 95% of the students in the class got a mark between 45 and 85. Yeah, that's a pretty big range, right? You know, there's like 40 marks to obtain there, so that makes sense at 95%. And 99.7, which is essentially everybody, almost everybody in the course got between 35 and 95 in the course. And that makes sense. You might have one person, if that, to get a mark that's either lower or higher, right? So that's what this information is telling us when we're talking about normally distributed data. We talk about our standard deviation, and we're always talking about deviating from the mean. And it talks about how much percentage of a population falls within an area. Okay? Now, to help us find, like for instance, if I was trying to find, well, how many people have a mark less than 85? Okay? That's when we start getting into a table called Z-score tables. And we'll talk about those a little later. Okay? But essentially, it's a table like this, and we look up Z-scores. And to find our Z-scores, we have to take our new value, subtract the mean, and divide by the deviation. And it'll give us a Z-score, which will help us find what percentage of a population falls, before a number. And it's always to the left within Z-scores. Okay, so we'd actually have to do subtraction to find it to the right. But this should give us a general idea.